So I have taught you many experiments to prove that characteristics of particles of matter. Have you all tried anybody? At least one or two? Any one of you? Okay. So that's fine. So we have been proved characteristics of particles of matter in our last class. Many experiments it is. So first one, you can notice it. We have been made it the size to prove that size of the particles are very small. So we have done one or two experiments, and the next one to prove that second one. What is the second property? All of you. Inter.
Space have
Interparticle
intermolecular space.
space.
Okay. So intermolecular space, or we can say interparticle space. So to prove that interparticle space, also we have done that activity, how the things will be spreading, and as well as the next one, third property. What is the third property? Motion.
Motion of
Motion
particle.
of particles. So we have been proved with the help of two things. One is with the help of what? With the help of diffusion, we have proved particles are continuously motion. And the second type of one, what is that, everyone? Yes, please. With the help of Brownian motion, we have been proved that particles are continuously in motion. Is it right or wrong, everybody? Yes, please. So from this, all these three, you can find it. Ultimately, we can make two conclusions about nature of the matter from the existence of Brownian motion. So we can make, what is that? The matter is made up of what? Ultimately, same thing.
Small,
The matter
small
is
part.
made up of tiny
Tiny particles.
particles. Understanding? The matter is made up of tiny particles. And the second conclusion, what we can make? The particles of matter. Particles of
Has
matter.
space between.
No, continuously in what? Constantly moving. Understanding? They are moving constantly. So that is what? Constantly moving. So these are the conclusions we can make with the help of Brownian motion. So now today's class, we are going to discuss something about effect of temperature on the rate of diffusion. How the temperature will be affecting, that is what we can say, rate of diffusion.
Sir, force of attraction.
Yes, Mari. I will discuss Mari. Force of attraction next, actually. Clear? So before that, we must know this. Clear? That is what. So rate of diffusion. Rate of diffusion. What is the effect of temperature? Okay. Effect of temperature on rate of diffusion. So we discuss now, everybody, how the temperature will change the rate of diffusion. Is it okay, everyone? Please respond. Okay. Now, so to prove this, let me take all of you. You might be all experienced in our daily life also. Let me take very simple example how the temperature will be affecting the rate of diffusion. Shall we start, guys? Everybody, are you all clear? Now, so take two containers in our home. All of you, just if possible, you can take it. So all of you, when we take the two containers, everybody remember. So this is the container one and I'll take the another container. Now you can see both I have taken a 100 ml of water. What I have taken, everybody? 100 ml of water. So this I have taken a cold water. I have taken a cold water and this I have taken a hot water. Same hot water or I am heating it. Hot water. Now I will add 1 tablespoon. Let me take a 50 grams of sugar. I have added 50 grams of sugar to it. Okay, and here also one with the help of 1 tablespoon, I have added 50 grams of sugar. Now you tell me in which container the sugar will be disappear very fastly. I have added the sugar. So now here also I added the sugar. So now which container you might be noticed in our daily life also. Can you tell me which container the sugar will be
The second container.
all of
The
you?
hot water.
Yeah, hot
Sir,
water.
in the second,
Yes, please. What is the reason, guys?
sir,
Because
because of the temperature,
The temperature is high.
the
So the
kinetic
kinetic
energy.
energy
The
will be high.
temperature
the
is increased,
temperature is
kinetic
more
energy will
here.
also be high.
The temperature is more here, then the rate of dissolution is very higher. Is it yes or no, guys? All of you? Yes, please. So the rate of dissolution means more fastly the sugar will disappear because more fastly it will get the energy to dissolve because of hotness. That is what the high temperature. So that is what by doing, even you can see when, yeah, no, it's not kinetic energy, it is because of temperature. So you might be see if you are trying to dissolve a sugar in normal water, it is very, very difficult to dissolve. But if you put the same sugar in a coffee or tea, you can see preparation of coffee or tea, it will be dissolved very fastly. Why it is? Because by the time we are heating, we are providing the external heat or energy outside, so to increase the rate of diffusion more faster. So that is the reason, all of you remember, as the temperature increases, so the particles of a solids which has taken, so what will happen? They will gain the energy. So as they are gain the energy, so they will started dissolving more faster. Because why? The particles kinetic energy will keep on increases, as well as liquids also. So not only kinetic energy of solids, the kinetic energy of what? Kinetic energy of solids, and as well as what? Everybody, liquid particles. So everything will start increasing. So if the kinetic energy increases, what will happen? All of you, as a result of the rate of mixing, the rate of diffusion will be very, very faster. That is why the solids will dissolve more quickly in hot water than in which water, guys? Than in which water? Cold water. Clear, everybody? Please respond, guys. All of you?
Yes, sir. Yes, sir.
So that is what. So from that we can say hot water and cold water. We people can say that is what is going to happen. So please all of you write. As temperature increases, write it. As temperature increases, as temperature increases, as temperature increases, the kinetic energy of the particles. Mr. Darshan, are you writing a notes? The kinetic energy of solids as well as liquid increases as a result of which the rate of intermixing increases. Clear, everybody? Rate of intermixing is increases. So therefore the solids dissolves where? It will dissolve very fastly. Dissolves quickly in which water, guys?
Hot water. Hot water.
Hot water.
Hot water.
Boiled water.
Hot water.
Than in cold water. Clear, Shivani, Sangamitrai? That is what.
Yes, sir.
We can even understand the effect of temperature on diffusion of solids into liquids. That's fine. Now, of course, solids are dissolving very faster when the temperature is more. That is what we have been understand. Now, let us understand what is the rate of diffusion of gases when the effect of temperature, how the temperature is affecting the rate of diffusion on gases. So let us see that. So for this one, we don't need to do any kind of big experiments and all. So just very simple. You might be burning the agarbatti for God, or else for this mosquito sticks. Nowadays, mosquito sticks also coming like agarbattis. Yes or no, guys? Incense sticks. Clear? So it is a common observation. That is what in the fragrance of perfume, you can see it will be fades very, very fast. Particularly if you'll observe. Now we are in what season? Now we are in what season, guys?
Summer season.
Summer season. Understanding? Now, if suppose I'm standing in a room now, if you observe very carefully, now if it is a summer season, if I spray the perfume here, all of you remember, now it will be passing to the entire room, and very fastly the smell of the perfume will be faded away. But if you take when we are in summer, understanding? Now, when we are in a winter, you can see the smell it will take more time to leave from our cloth even. If you suppose spray to our body, in winter season, it is very, very difficult to lose that perfume smell. But if you take in summer, it will be very fastly, it will be faded. Can you tell me what is the reason? Anybody? All of you?
Sir, because of temperature.
Yes, temperature. In summer, now you can see it's very, very high humid. So, like these seasons, you can notice it. The because of temperature, the air particles are dry air, means the particles are moving very faster, so that they will take the perfume smell very longer distance very quickly. So that is the reason the perfume will be fades faster in which season, guys? Fades faster in summer
Summer
as
season.
compared to understanding compared to winter. So this is the one of the best example everybody will experience in our daily life. So winter season, if you spray the perfume, it will take more time to lose that smell, fades that smell. But in summer, very fastly it will be faded away. Now, or else you might be noticed it as yesterday one girl said, if your mother is cooking the food in kitchen, that food smell will come even into your hall, or if you are in a bedroom also. Is it right or wrong, guys? All of you? Yes, please.
Yes, sir. That is
So
because
that
when
is what we used
heat,
to call the smell of the food. We used to call as aroma. What we used to call? Yes, everybody. Aroma. Understanding? So if you notice it, if your mother is cooking in the kitchen, the aroma of the food spreads the nearby rooms. Means if you are in a near bedroom or near hall anywhere, so definitely you people will get, particularly in Sunday time, definitely we people will get more smell. Is it right or wrong, guys? And based upon the smell, we can estimate what curry your mother is preparing, and your mouth is also start watering. So that is what. So the aroma of the food spreads in the nearby rooms. But if you take here, let us take how it will be. Even the same thing here. If it is the smell of that, if it is summer season, again same. So it will be spreading very fastly and it will be faded very fast. We won't get that much. If it is winter season, you can see the smell of food or even the smell of a any kind of soups and all will be experiences very nicely in the winter season. Yes or no, guys? All of you? Yes or no? When you people will have the soup, winter season or summer season? Soups and all. Summer season you are having soup. Who is that girl?
Winter season.
Winter
No,
season.
sir.
Yeah. So that is what. So now let us observe this effect of temperature on continuous motion of gaseous particle. The best example is this mosquito incense sticks, or you can see agarbattis.
one doubt, sir.
Yes, Mari.
Sir, in summer season only, no, in winter season only, no, sir, it gets faded up. The rest
No,
gets faded up, no,
it
sir.
will take more time, Mari, to fade it up because it will travel very slowly in the
Yes,
air.
sir.
Understand, Mari?
Yes,
Yeah,
sir.
yeah, but in summer season it will be travel very faster, so it will be go away from you very quickly. That is what I'm saying. Understood? Yes. Okay, Mari. So now I am taking the incense sticks and I kept in our home, which is actually already burning. So that now burning in the sense of, so I'll just show you the red color. So immediately it will produce something. Can you tell me what is that? All of you? So smoke is started spreading. Understanding?
Smoke.
Yeah, smoke is started spreading throughout your room. You can see if your mother is putting in the if your mother is putting this incense stick, suppose in the God's room, so that the smell will be spread throughout the house. Is it yes or no, guys? Slowly it will be yes or no. So if you put anywhere in your classroom or in your kitchen, or if you are in front of your God or whatever it is, so place just unlit incense sticks. This is what we used to call as incense sticks, or we can say our Tamil. What we can say, guys? Incense sticks. Agarpula.
Udapati.
Udarbatti, whatever it is. Telugu, we can say agarbatti. So that's fine. So this is what. And if you put unlit light, incense sticks on a table, are you people are going to get any smell? Unlit. Yes, please. unlit one. So we are not going to experience any kind of smell. Now, if I put fire with the help of a matchbox, so I'll just light the incense sticks with the help of a burning matchstick. Now you can see all of you. So you can, if you notice it, the incense sticks. Have you noticed that fragrance from the incense sticks as soon as if you are putting the lightning? If you just light it, all of you. So what will happen?
Yes, sir.
The incense sticks will start burning. Understand? And it will be started producing smoke slowly. Okay. So the smoke is only actually the fragrance. So it will be slowly spreading throughout the room. Now, if you notice it, if you unlit the stick, before unlit the stick, the particles are very, very low kinetic energy. So it will take more time to smell it. Even the agarbattis, the incense sticks, normally also they will smell basically, but the smell is not very long distance. It will be. So if you're having a incense stick in your hand, you people can experience the fragrance because they'll be made with some kind of like special fragrance which will make to attract. So that will be. But if you unlit the stick, the particles are very, very closer and they are not having much kinetic energy. So that is why the fragrance cannot be like appears to be long distance. But as soon as if I put the fire, if I lit the sticks, incense sticks, what will happen? These particles of matter, they will be in a continuously motion due to the fire. They will be converting into the gaseous particles, and these gaseous particles, they will continuously more fastly they will move, because by the time they are having kinetic energy is more or less. Yes, please. Due to the high kinetic energy, understanding? So due to the kinetic energy, they will be moving very, very faster. So when the temperature increases, the kinetic energy of the particle keep on increases. That is why when we light an incense stick, it will produce us immediately gaseous particles who is having the fragrance. Gaseous particles having the fragrance. Okay, so that fragrance only very fastly it will be spreading in our room, so that we will experience the smell very quickly. So that is why as when we light an incense stick, it will produce us more and more smoke like things. That is what gaseous particles having that smell. So these molecules acquire more kinetic energy and will spread in large area where we can smell it from a even a long distance. So if your mother is putting in front of the god or somewhere, you can see it will be spreading even in your two rooms after also, because when we light it, they will get the particles of this one, they will attain large kinetic energy, so that more faster they will be
Sir,
spreading into the all the air, through the air it will spreading into all the rooms. Yes, Mari?
sir, one doubt, sir.
Yes.
Sir, all sublimation using objects like
Yeah,
even
of course. But sublimation,
agarbatti
but if you notice
and
it, Mari,
also
sublimation
naphthalene
kinetic
bulbs.
energy is less, Mari. Do you understand that? Kinetic energy is less. Purima.
Yes, sir.
Yeah.
Even in naphthalene bulb it produces some smell, no, sir.
Yes, Mari, that's
And
what
in
I'm saying.
agarbatti also.
Agarbatti also before lighting, it will be produce a smell, but the smell is coming very long distance. That's what my question. If you take agarbatti in your hand, are you experience the smell or not? Yes or no?
Yes, sir.
Fragrance. But that fragrance won't come to your sister or your mother who is sitting in the another room. But if you light the incense sticks, what will happen? Then the particles will turn into gaseous. Understanding? So gaseous particles it will turn, and they will acquire more kinetic energy because of burning. So that more fastly it will spread into the air, and very fastly it will be diffuses from high concentration to low concentration. So it will be spreading into the long distances. Okay, Mari? Clear?
Yes, sir.
Yes. So that is why you tell me. So diffusion of particles, where it is faster, gases or solids or liquids? Everybody.
Gases.
Yeah.
Gases. So diffusion of particles in gases is faster than solids and liquids. That is what you have to remember. Okay. and you can write it. Diffusion rate, where it is faster, all of you, compared to solid, liquids and gases. Diffusion is faster in where? Diffusion, gases
Gases.
is greater than next one. Liquids, it is greater than next one is what? All of you, solids. So diffusion is very slow in the solids. Next, compared to solids, liquids is little bit more, and compared to liquids, gases is more. Diffusion rate is, this is how it will be. Is it okay, everybody? Please respond, guys. So why the
Yes,
diffusion rate is less in solids? Anybody can tell me what is the reason? What is the
Sir,
reason?
because
Diffusion
when
rate?
tightly packed, one
Yeah.
vibration occurs.
Because of particles are very closely packed, so that they will be always moves only to and fro motion. Understanding, everybody? To and fro motion only. So they won't be displaced from one place to another place. So that is the reason the force of attraction is very, very more between the solids. That is why diffusion rate is very, very lower, more. It will be very, very less. Understand, everyone? So that is what you have to remember. So kinetic energy in which one? Yes, Kishore. Solids to gas illa Kishore. Incense sticks, if you notice it, incense stick is a solid, Kishore, but heating it will be converting into gas. Understand, Kishore? Gas particles, and then only
How is
diffusion
it
will start.
possible to convert without liquid into gas, sir?
Which one?
What is
Mari?
the process?
Which
into it,
one?
sir?
Which one?
The sublimation process.
Sublimation actually they will never form the liquid state. That is the problem with the
Then how, sir? How it occurs?
how it will occur means at that temperature. For example, if you take the carbon dioxide normal room temperature, what is that, Mari? Normal room temperature, they will be in a gaseous state. Yes or no? Okay.
Yes, sir.
Now if you bring it to the minus 75 degrees and below temperature minus 75 degrees, it will be directly compressed. Till that it will be in a carbon dioxide gaseous state only. Understand, Mari? If the temperature will
Yes,
go
sir.
as soon as 75 degrees minus, immediately it will turns into a dry ice. That is what we can say solid carbon dioxide. Do you understand?
Yes, sir.
So there is no liquid forming because till the temperature it will be in a gaseous state only. As soon as the temperature goes below that, directly it is forming solid. No liquid is forming. That is why we can say it is a sublimate product. Understand?
Yes, sir.
Between the temperature,
Yes,
no
sir.
liquid state is existed. That's the reason they are called as sublimates. Okay, Mari?
Yes, sir.
Yeah. So now if you observe very carefully, so as we know, diffusion rate is more fast in gases compared to liquids, and liquids it is more fast in solids. Now you tell me kinetic energy. Kinetic energy, no, it is not sublimation, Abhirami. Converting the agarbatti into smoke is not a sublimate because we cannot bring the agarbatti back from smoke. Is it okay, Wa? That is not takes place, and that too we are providing the external energy. It is not, it is called as a sublimate product. Okay. No, Lingesh, I have not taught. I'll teach you again. Okay, Lingesh, I'll teach you next.
Okay.
Yeah, next diffusion rate. So who is having more kinetic energy? Gases, liquids, or solids? That is also tell me. All of you. Particles in liquids having yes,
Gases.
gases. So kinetic energy. So kinetic energy is gases is greater than liquids and greater than what? Solids. So
Solid.
compared to solids, liquids having higher kinetic energy. Compared to liquids, gases is having more kinetic energy. So please make these two relations. Everybody, do it. Are you clear, everybody? All of you? Yes, please respond. Yeah. Now, one more additional information I'll teach you. So that is regarding liquids alone. Please, all of you write. Liquids alone, one special important thing regarding diffusion. I want to know either all of you taking the notes or not. Please respond. Yes,
Yes, sir.
so write it
Sir.
liquids.
Yes, sir.
Right. The diffusion in liquids depends upon the diffusion in liquids depends upon the thickness of the liquid. Thickness of the liquid. Yes, please. Thickness of the liquid. Okay. So thickness in the sense of we used to call it as viscosity. Of course,
Sir,
we will
can you
study.
please say that again, sir?
Yeah, the diffusion in liquids depend upon the
Sir,
the
can you please say that
yes,
sentence again,
Mari, I
sir?
am saying you. The diffusion in liquids depends upon the thickness. The diffusion in liquids depend upon the thickness of the liquid. The thickness only we used to call. What we used to call, guys? Everybody respond. Viscosity.
Viscosity.
Okay. So now let me take for
Viscosity.
example all of you. So I will take it two beakers, and one beaker I will fill with the water, and another beaker I will fill with honey. All of you observe. This is the honey, and this is the water. So this is honey, okay, and this is the water. Now I will add sugar, 50 grams of sugar, and here also 50 grams of sugar. Now tell me where diffusion is very fast. All of you. Water.
Water.
All of you.
Sun, water.
Water. How many of you will say water and how many of you will say sugar? Oh, sorry, honey. Anyone is there who will say sugar, honey? So now you can see honey, viscosity of honey is more. The thickness is very, very high. Is it yes or no, guys? All of you? Yes, please.
Yes, sir.
Viscosity
So
is
that
more.
it is
For example, I will ask you to walk through the water. I'll ask you to walk through the honey. So which you people will feel easy to walk?
Water.
Water. Because
me.
water viscosity is less, so that more fastly the particles can travel, so that it will be diffuses very fastly. But honey, the thickness is very, very high, so particles cannot be travel faster. Do you all understand, everybody? Yes, please. Yeah. So that
Yes,
is
sir.
why diffusion in liquids also depends on one more parameter. What is that? All of you. That is what? Viscosity. Of course, diffusion in liquids is greater than solids. But if I compare one liquid to another liquid, in which liquid is diffusion is more faster? I have to check what? Immediately I have to check it what? Viscosity.
Viscosity.
That is what you have to remember. So write the statement. The more the viscosity of the medium, the more the viscosity of the medium, the more the viscosity of the medium. Shivani, are you writing? Viscosity of the
Yes, sir.
medium. The more difficult it is, the more difficult it is for the molecule to move. For the molecule to move, the less the diffusion rate. The less the.
Sir, can you repeat it?
Yeah, I am writing diffusion rate. All of you remember, the more the viscosity of the medium, the more the viscosity of the medium, the more difficult it is for the molecule, the more difficult it is for the molecule to move, comma, the less the diffusion rate. Understand, Mr. Sanjay, Gokul Ras, everybody? So viscosity is increases, rate of diffusion is decreasing or increasing? Everyone, rate of diffusion is decreasing. That is what you have to remember it. Okay. So this is what about the characteristics of properties of a matter. Now the next characteristics of a properties of matter. So that is what the particles of matter attract each other. So let us prove that.
Sir, can you please down the screen, sir?
Okay. The
1
particles
minute.
of matter attract each other. So that is our next concept. So let us discuss either the particles are attract each other, they are having the force of attraction is not. Okay. So that is what we used to say, force of attraction. So let's start.
So one doubt, sir.
Yes, Mari.
Sir,
Tell me, Mari. Can you hear me?
sir, I'm just having a little bit network struggle, sir.
Tell me.
Sir, can you please down the screen, sir? In that, sir,
Tell me.
sir, in that it is for the molecular. What is it, sir? Next to that,
Molecule to move. Molecule to move.
molecule
to move, M-O-V-E, move.
Yes, sir.
Okay. So the less
Yes,
the
sir.
diffusion rate. Understanding? So means the molecules, if you have taken the sugar particles, they cannot be moved freely in the honey, but they can move very freely in the water. That is why in water diffusion is very faster than honey. Understand, Mari? Okay, wow. Like viscosity is greater, diffusion rate will be less. That is what you have to understand. Okay, Mr. Kishore, Lingesh, understood?
Yes, sir.
Okay, good. So next one. The next concept is the particle of matter attract each other. Particle of matter attract each other. Okay. So let us first listen, everybody. Once you understand the concept, then we can write it very easily. So you might be see that in our daily life, we can come across with so many substances in our things. For example, you can see, have you ever thought in our surroundings while you are coming, so wherever you are traveling, you see many of stones, big stones, small stones and all. Have you ever tried that? Why can't we break the stone like a crunchy biscuit like your favorite biscuit or any kind of things like uh, what we can say that vapors and all, like vapors or biscuit or like a chocolate. Why can't we break it like a Kit Kat chocolate or Munch chocolate? Have you ever thought why stones cannot be like a crunch enough like biscuits? Anybody?
That is solid.
So
Yeah,
because in the
of course.
stones, the
It has
particles are
high
Yes,
force of
Mari.
attraction.
Yes, Mari. Yes, Mr. That girl. Who is that girl saying?
It is
So,
slightly
yeah.
packed.
So if you notice it, why can't? Yeah, of course. That biscuit is also tightly packed only. Yes or no, Mr. Lingesh? Correct or not?
Or it has high force of attraction.
So
Yes.
it has
Why
high
can't?
force.
Yes. So you can see that. Then, if I give you a single paper, have you all experienced everybody? Single paper. Do all people easy to tear it? Is it right or wrong? If I give a single
Yes, sir.
paper, all of you. So single paper, if I
Yes,
give,
sir.
you people can easily can tear it or cut it. Now, if I give you, for example, a very it's a very thin sheet, like 100 pages is attached one another, and I have given you. So, is it possible to tear it? Anybody?
No, sir.
No. You all
No,
understand?
sir.
So that is the reason. So what if I given a bundle of paper? So it is very difficult to even cut it, or we cannot tear the bundle of paper easily. But single paper means we can. So you might be experienced. Now, have you all noticed mercury? How many of you know mercury? Here, mercury,
Yes.
mercury symbol is Hg. Hydrogyrum we used to call it. Scientific name is hydrogyrum. So have you all noticed it? If you try to capture the drops of mercury with your fingers, understanding, you cannot. But two drops can be clinched together when they brought closer. If you notice it, one drop if you try to capture with your hands, like holding in your hands, you people cannot. But if I two drops, if I put mercury closer, then both they will attract each other and they will be cling together. Understand that, everybody? All of you? Yes, please respond. So this is all. What is the reason?
Sir.
Can you tell me this everything? Why can't the stones are crunchy? Why the single paper can be teared but bundle paper cannot be? A single mercury drop cannot be captured. They do not capture the drops of mercury with our fingers, but two drops can cling together when they brought closer. So what is the reason? Anybody? Yes, please. Due to the what is the reason? Due to the one and only reason. Everything is what? Due to the
Force of
Force
attraction.
of attraction.
attraction.
Force of attraction.
Due to the force of attraction among the particles. Among the particles. So that is the reason you can see that is only we used to called as interparticle force of attraction, or we used to called as force of cohesion. What is to call? All of you? Force of cohesion. I will teach you that. Okay. So now, if you observe very carefully, due to the force of attraction among the particles only, so these are behaving like this. Now, the force of attraction of same particles, all of you remember, mercury, paper and paper, and next one, stone particle and stone particle, like a particles of a same matter. What is this, everybody? Particles of a Pranav? Particles of a same matter, then you can see the force of attraction present between particles of a same matter we used to called as force of, what we used to call, please remember, force of cohesion, or we can say interparticle force, interparticle force, or we used to say force of cohesion. All of you remember cohesion means force of attraction between same particles of same matter or different matter. All of you.
Same
Matter. Okay.
Same matter.
If the force of attraction present between particles of a different matter, okay, different matter, then that is called as force of adhesion. Okay, force of adhesion. So have you all noticed in our bags, if you are having a glue bottle, check it everybody. They used to written adhesive. Have you checked it anytime? Mr. Sanjay, Lingesh? Yeah, glue bottle. If you are having a glue bottle in our bag, verify it. They used to write for adhesive glue, like that they used to mention. Have you checked it everyone? So means in the sense of that adhesive we will use to join two different substances. Understand? So how it will be different, I will say. So we'll discuss it. So if I take two different particles of a, that is what, particles of a different matter. So for them also the force of attraction is present. That force of attraction only we used to called as force of adhesion. Same particles, whatever the force is present, we used to called as cohesion. Or somebody told something. Yeah, Sanjay told. Adhesive they have written. Have you checked it, Sanjay? Everybody others, you check it. It is written adhesive in our glue bottle. Have you checked it? Means in the sense of which will be used to join the particles of different substances. So that is why we used to, that is mentioned as a adhesive. Verify it everybody. Clear everyone? So meeting is going to end. Please join. So this is what we used to call as force of attraction. So due to this type of packing and as well as you can notice